Recording polar equations, part 1. I mean, recording polar equations, not recording polar. What did I say? Graphing polar equations, part 1. So, graph R equals 3. So, if you have a problem like this, and I don't have a note sheet for you, so you guys are going to have to take some notes. So say we have this problem, graph R equals 3. Graph R equals 3. Anyone know what that might look like? Oh, how do you know that, Trevor? Trevor guessed. So if you were to graph this, R equals 3, and you're graphing in polar form, I guess I should have a polar grid, but I don't. The radius is always 3, right? So what Trevor said is exactly correct. What this makes is a circle, right, with a radius. I didn't want to start it there. With a radius. How do you move it? Right here. With a radius of 3. That's what that would mean. Right? Because wherever you are, the radius is always 3. Now to change that into a rectangular equation, you would go like this. You multiply both sides by you square both sides. So square both sides. Square both sides. And you would get r squared equals 9. What's r squared equal to? X squared plus y squared equals 9, which is indeed the equation of a circle with a radius. Okay? And that's how you do that kind of thing. Now, what if I had something next? What if I had something like this? Graph. Can I choose a different color? Graph theta equals pi over 4. What do you think that looks like? It's a line, because what this is, right, it's a if I were to draw an axis here and here, it's a line that always has a slope of pi over 4, or not a, it has an angle of pi over 4, so that angle that it makes with the polar axis is going to be pi over 4, which is 45 degrees, right? So this one, if I drew it like this, goes through the origin, like that, and this angle right here is, this angle here is pi over 4. So that just makes a line. Okay. Now, if you want to change into rectangular form, that's kind of tricky. Into rectangular form. What you have to do is take the tangent of both sides. So I'm going to take the tangent of both sides, and the tangent of theta equals the tangent of pi over 4. What is the tangent of pi over 4? 1. So I get 1 equals the tangent of theta, right? And then I also know that if I were to draw down here, if I were to draw like this and like this, this here is y, and this is x. So what's another way I could express tangent of theta in terms of y and x? Y over x, right? If this is theta. So this is equal to y over x. and you get y over x equals 1. So y equals x, which is indeed the equation of a line with a slope of 1. See how that works? Isn't that cool? You don't think that's cool? Cool. Alright, so next type of thing that you're going to see is, this one's easy. Oh, I don't want that kind of paper. What happened? Oh, I want this kind of paper. R sine theta equals 2. Easy. Graph and convert to rectangular form. Easy. I think the easiest thing is just to convert this to rectangular form. What's r sine theta equal to? Y, right? So you just get y equals 2. What's a line with a what's a line look like that has an equation y equals 2? It's a horizontal line through 2, right? So if I were to graph this one, okay, I'm going to get, okay, I'm going to get a line that is going up here through 1, 2, whoops, 1, 2, right there, and it's going to go across through right, oh, what happened? What's under there? You want our tool, that tool. So it just goes like that. Problems with that? Easy? Yeah. It gets harder though, don't worry. I think you could graph other ones like that. But now let's do one like, what if I have r sine, so what I have? R equals 4 sine theta. R equals 4 sine theta. So some of you already know what this is. What shape does that make? Anyone? No? We'll learn more about what specifically each type of polar equation, what each form of polar equation makes. But this one, so convert and graph. Convert and graph. Now you don't always have to convert them to graph them, and we're going to talk about that next week. Okay, but I would multiply through by r first. So you get r squared equals 4 r sine theta. We did this kind of in last night's homework. And what's r squared equal to? X squared plus y squared. And what's r sine theta equal to? Y. So you get this. Now they want you to make it into the equation of, this is an equation of a circle, but we need to get it into a more familiar form, kind of what I taught you yesterday. So you're going to bring the 4y onto that side, so you get x squared plus y squared minus 4y. We did this exact same problem. And then I get x squared, and I complete the square on this part. So what goes, y minus what? 2, right? Because that's half of the negative 4y. That's how you complete the square. Equals what? What did I add to this when I just did that? 4, right? I add a 4, so I need to put a 4 over there. And this is the equation of a circle with the center, with its center at 0, 0, 2. So the equation of a circle with the center at 0, 2, right? And a radius of square root of 4, which is 2. So if I were to draw this using my cool tool, I got a cool tool, I get that circle. It doesn't have to be dotted, but let's not make it dotted. So I'm going to start here with my circle. circle, and I'm gonna start here and boom, there it is. Okay? If you graph this on your calculator in polar form, you would also get a circle with a radius too. But we're gonna kind of do a lab on that and see about graphing while in polar form. All right, what else do I have for you? Circle with radius 2, and I think you could do one more, and then we'll be done. Okay. And these are just for today. It's just circles and circles and lines and circles and lines. See you later. Good luck. So if I have something like this, next one, last one. R cosecant theta equals 9. R cosecant theta equals 9. I want to rewrite this somehow that I can deal with. How can I rewrite cosecant? 1 over sine. So I could write this as R over sine theta equals 9, right? Which means that R equals 9 sine theta. Then what would I do? Just like I did in the last problem. Multiply by R. So I get R squared equals 9R sine theta, which means that X squared plus Y squared equals 9Y, which means that X squared plus Y squared minus 9Y equals 0. Now sometimes you'll have to complete the square with the X part too, but just so happens these two problems are set up like this, which gives me X, which gives me X squared plus Y minus what? 4.5 squared equals 4.5 squared. What's that? 16.25? 16.25. And then, so this is a circle with a center at 0, 4.5, and a radius of 4.5, right? And that's kind of all I'm teaching you for today, okay? Next time we'll learn about ellipses and hyperbolas and cardioids and all kinds of more interesting polar graphs. What's wrong? Oh, so Max playing with what happens when I graph other types of functions. And you can get some really cool things. And we're going to go to the computer lab and do all that based on this. All right. So, that's good stuff. I don't need that.